Okay, let us continue the second part of today's class. Okay, in part 1, we have taught to here. Okay, this is section 1.9.2 matrix property G. Okay. Let A and B denote any two matrices having the same dimensions n by n, and small a denote any non-zero scalar. Then 1 over small a to the power of n times the determinant of capital A plus capital B is equal to the determinant of capital A over small a plus capital B over small a. Okay, this is the section 1.9.2G. Okay, so let us go back to the Microsoft Word. Okay, so we know that a to the power of n, okay, and times the determinant of matrix A and plus matrix B is equal to matrix A over A plus, okay, this should be italic, okay, plus matrix B, okay, matrix B over smaller scalar A. Okay, we call this equation 1. Okay, like this. Okay, where the matrix A and the matrix B denote any two matrices having the same dimensions n by n. Okay, and A denotes any non-zero scalar. Okay, now let A be equal to I n r. Okay, and B the n should be a boldface. Okay, and B is equal to a zero matrix of the dimension nr times nr. Okay, like this. And n is equal to nr. and A is equal to 1 over sigma square. Then equation 1 becomes so A is equal to sigma square, 1 over sigma square. So we can copy this and paste here. So A is substituted by 1 over sigma square. Like this. And N is equal to NR. So N is equal to NR. And A is equal to INR here. And B is equal to 0. NR times NR. Here. So again, here A is equal to 1 over sigma square. Here is also 1 over sigma square. And A is equal to INR. And B is equal to 0. NR by NR. Then it applies that sigma square to the power of NR times the determinant of INR. The zero matrix can be cancelled like this. And this is equal to again we cancel the zero matrix term, and the sigma square can be moved to the numerator. So sigma square times INR like this. This should be here. Sigma square to the power of NR times the determinant of INR is equal to the determinant of sigma square times INR. And this implies that right arrow the determinant of sigma square times INR is equal to sigma to the power of 2NR and times the determinant of INR. Like this. So this should not be in the power. So let me see if I can align at this right arrow symbol. So let me copy a right arrow and good, very good. And I make this right arrow white. Like this. And we call this equation 2. Like this. Next, omitting the subscript NR. we get. Okay. Okay, so we omit the subscript. Okay, like this. And here also omit the subscript. Okay. So the determinant of sigma squared times I is equal to sigma to the power of 2nr times the determinant of I. Okay, and this is equation 3. Okay, therefore, okay, 1 over 2. Okay, that is the third line of the equation 2.32. Okay, so we can copy here. Okay, 1 over 2 log 2. And of the determinant of H times RSS, okay, times H transpose plus sigma squared times I over the determinant of sigma squared times I. Okay, so this is equal to, okay, let us copy this and paste here. So according to equation 3, the determinant of sigma squared I is equal to this term. So we can replace it here. So this is equal to sigma to the power of 2nr times the determinant of I. And this is the equation 4. Okay, good. So let me enlarge the font size. Okay, and insert a QED symbol. Okay, black square and write a line. Okay, so this completes the solution. Okay, do you have any questions? Okay, if you do not have any questions, okay, let us save this and go back to the slides. Okay, so we have derived the fourth equality in equation 2.32. Okay, we can now use the fact that the determinant of I is equal to 1. C matrix property section 1.9.2f. Okay, let us see the this. Okay, matrix property section 1.9.2 f. The determinant of any identity matrix is 1. Okay, and matrix property 1.9.2g. Okay, let us see matrix property 1.9.2g. Okay, so okay, this. Okay, so we have seen this in the part 1 of today's class, so I think I do not need to read it again. Okay, to simplify equation 2.32, equation 2.32 is this equation. Okay, C real is equal to this equation to the following. Okay, we can see that C real, the capacity of a real signal, is equal to 1 over 2 times log 2 of the determinant of I plus 1 over sigma square times H RSS H transpose bits per channel use. Okay, so I will explain what is the meaning of this unit bits per channel use later. Okay, so now let us see how to derive this equation. That is equation 2.33. Okay, so please see the blackboard. Okay, again, I do not have a blackboard, so I use Microsoft Word instead. Okay, chapter 2, page 105, problem 1. Derive equation 2.33. Okay, and problem 1 should be boldface. And the solution. Okay, from equation 2.32, we know that solution should be boldface. Okay, so we know that. Okay, let us go back to equation 2.32. Okay, C real is equal to this equation. Oh, sorry. Log should be HRSS. Okay, this should not be italic. So I should not be italic. Okay, so this is equation 1. Okay, next we can now use the fact that the determinant of I is equal to 1. Okay, determinant I is equal to 1. Okay, please see matrix property section 1.9.2 F. To simplify equation 1 to the following. Okay, so C real is equal to this equation. And now we know that the determinant of I is equal to 1. Okay, so we can delete this term. And we call this equation 2. Okay, then we can now use matrix property 1.9.2 G. Okay, like this. Okay, so let me copy the this property here. Okay, so let A and B denote any two matrices having the same dimensions n by n, and A denote any non-zero scalar. Then 1 over small a to the power of n times the determinant of capital A plus B is equal to the determinant of capital A over small a plus capital B over small a. Okay. Okay, now we let A is equal to sigma square and N is equal to NR and A is equal to A should be boldface. A is equal to this term. H times R is times H transpose and B is equal to this term. B should be boldface and not italic. So B is equal to sigma square times I. Then equation 3 becomes so we can copy equation 3 to here, and we replace A by sigma square. Parenthesis. Here, and sigma square. Like this, and replace A by this term. So replace B by this term. So again, replace small a by sigma square. And matrix A by this term, and the matrix B by this term. Oh, sorry, I forget to replace small n by capital NR. So after the replacement, 1 over sigma square to the power of NR times the determinant of H times RSS times H transpose plus sigma square times I is equal to the determinant of H times RSS times H transpose over sigma square plus sigma square times I over sigma square. So it implies that fraction. This is the numerator. We copy this here, and the denominator sigma squared to the power of NR can be written as sigma to the power of 2NR. Like this. And this is equal to this equation. And we can see that the sigma square and sigma square can be cancelled. And the remaining term is I. And we can move the term I here into the first term. And the plus, sigma square, we can move it in front of the matrix. So this is equal to 1 over sigma square. Here. And times this term. Times this term. And we call this equation 4. It is 25 minutes. Let us take a break.